All right, this is problem 23 in chapter 1, section 2. And it asks specifically for lambda equals 1 and lambda equals 2. Let's start with the case where lambda equals 2, and we'll substitute in lambda equals 2. Oops, I said I'd substitute in 2, and there we go. And so what we can do is we can make a system of equations out of this. So I'll transform this by bringing x1 across. So I get negative x2 equals 0. I get 2x1 minus x2 plus x3. Oops. We'll bring the x2 over, so it's minus 3x2 plus x3 equals 0. And then in minus 2x1 plus 2x2 minus x3 equals 0. And so immediately we can see some of our variables here. As we know, x2 will always have to be 0. And if we look at these equations, then they become 2x1 plus x3 equals, well, if I negative 2x1 minus x3 equals 0. Now if I divide the negative out of here, I get the same equation back. So we end up with a system of 2x1 plus x3 equals 0. So if we let x3 equal s, then 2x1 equals negative s, and x1 equals minus 1/2 s. Now, the student solution does it the other way. It says, and this is the thing about parameterization, I tend to parameterize from the highest number variable to the lowest in order, but the student solution says, hey, let x1 equal the parameter t, then n x3 has to equal negative 2t. And you can see that these are equivalent. But let's look at the case when lambda equals 1. So I'm going to rewrite these equations, but with lambda equals 1. So I have 2x1 minus x2 equals x1. I'm going to have 2x1 minus x2 plus x3 equals x2. Sorry, I'm making sure I copy all my signs, right? Equals x2. And then I'm going to have negative 2x1 plus x2 plus x3 equals x3. We'll do the same thing. We'll pull variables over to the x side, to the left side. So x1 minus x2 equals 0. 2x1 minus 2x2 plus x3 equals 0. And negative 2x1, oh, that should be 2x2 plus 2x2 plus 2x2 equals 0. because the x3's cancel out. And visually here, if we look at these two equations, the only way they can exist, because if I bring the negative through, I have the exact same equation here, except this one doesn't have an x3. And so the only way these two could be the same is if x3 equals 0. Well, let's put this in matrix form and see what this looks like for our matrix. So we have 1, -1, 0, 0, 2, -2, 1, 0, -2, 2, 0, 0. Now, you'll find when we have equations where the solution side is all 0, they're called homogeneous equations. And the resulting answers actually tell us a lot about the coefficient matrix. But what we're going to do right now is we have a pivot here, so I'm going to clear down the pivot. So we're going to take row 1 times -2 and add it to row 2, and we're going to take row 1 times 2 and add it to 3. So 1 minus 1, 0, 0 exists. If I take -2 and 2, I get 0. If I take +2 and 2, I get 0. And if I do it on the last row, I'm going to get 0, 0, 0, 0. And so from here, we see that x3 has to equal 0, like we could see visually. And then we have x1 minus x2 equals 0, or x1 equals x2. And so we let x2 equal s and x1 equal s if we parameterize it. And I believe the solution in the back of some of the textbooks does not have this answer. It looks like it was trying to solve for another value of lambda. And so this is pointed out by another student, and we went through and worked it out, and this is the definite answer for this problem. And so what I wanted to do was look at possibility of what happened if lambda equals -1. So I'm going to rewrite the equation one more time with lambda equals -1, because just by inspection, I think that's what the textbook was trying to actually ask, but we'll try it and see what we get. So 2x1 minus x2 equals -x1. Sorry, I'm really triple checking my signs here. 2x1 minus x2 plus x3 equals -x2, -2x1 plus 2x2 plus x3 equals -x3. So we'll try that. And we'll see, again, just by inspection, this is the feeling I had that they were trying to ask, not lambda equals 1. But we'll see what result we get here. And so I'm immediately going to put this in matrix form. I'm going to get let me first transform by bringing across the x1s. So I'm going to get 3x1 minus x2 equals 0. I'm going to get 2x1 plus x3 equals 0. I'm going to get -2x1 plus 2x2 plus 2x3 equals 0. Right away, I can see these all have 2's, so I'm going to divide everything by -2. And I want to make this the first row in my matrix. So that's going to be 1, -1, -1, 0. I'm going to leave this the same, so it's going to be 2. So I'm bringing the second row across. 2, 0, 1, 0. And then I'll leave this the same. I get 3 minus 1, 0, 0. And so I have a pivot up above, so I'll take row 1 into row 2. I'm going to multiply it by -2. I'm going to take row 1 into row 3, and I'm going to multiply it by negative 3. So row 1 stays the same. Row 2, negative 2 plus 2 is 0. Negative 2 times, I'll get a 2 for here, and negative 2, 3, 0. And then on my last row, that pivot clears, and we get negative 3, positive 3 plus negative 1 is 2, positive 3, 0. These two will cancel out because they're exactly the same. Let me check this last one again. Negative 3 plus 3 is 0. Positive 3 plus negative 1 is positive 3 plus 1 is positive 2. And positive 3 plus 0 is 3. Yeah, so we've got two equations that are the same. So, adding row 2 or into row 3 by negative 1 will clear out row 3. So I get 1 minus 1, 1, 0. And I get 0. I'll divide everything by 2 here. 1, 3 halves, 0. And I get 0, 0, 0, 0. And so x3 is the only thing without a pivot. So I'll make x3 my parameter t. That means if I come back to here, x2 is equal to negative 3 halves t. And so when I come up to this line, I'm going to have x1 is equal to negative 3 halves t minus t, which is x1 is equal to negative 5 halves t. I'm not sure if that was the answer they were looking for in the back of the book. Again, the back of the book definitely did have a different version of lambda. So if we play with what we can get with different lambdas, we can see the parameterization changes. And this is actually something we'll want to explore more as we go on. If you have any questions, holler. Double check my signs on the negative lambda one, but this should work in getting you through the problems.